My name is Dmitry Schigel. I'm Scientific Officer in the Secretariat of the Global Biodiversity Information Facility, GBIF. And in the BioDT project, I'm leading the work package 4 on data use cases and data streams, together with Doug Anderson. The use case on the eDNA prioritization is trying to model and help sampling efforts for the eDNA monitoring. So eDNA and metabarcoding detection is a relatively new way to know what is living and where it is living, where life is located on the surface of the planet. And traditionally, biology relied a lot on the physical, optical methods to detect species and to identify them. It was true before the invention of the microscope, but with advancement of the optics, the principle of species detection and species identification remained the same. You need enough morphology to tell one species from another, and you need the very same morphology to put a name on your organism. It changed quite rapidly with the broader availability of eDNA and metabarcoding methods, because then you can do the same but chemically. So you detect using a molecule, and you also name that sequence, that molecule information, using digital interpretation methods. You compare your sequence of DNA that comes from your sample from nature to the reference library, and this way you can get understanding of who and how many and where lives. One cool thing about eDNA and metabarcoding is that it allows to know microbial life and to understand life in the environments which very often escape attention of general public. Cryptic environments such as soil, water, sediments of lakes and oceans, air, caves, wood interior, and things like that. So you look chemically to where very few people are looking, and you detect species which are pretty much ignored or bypassed by present-day conservation and legislation instruments. And it's a very important mission. We cannot really afford that all our data-driven decisions are made based on bird and butterfly and flower data. It's very skewed. It's very easy to present it this way to kindergarten children, but biodiversity monitoring and data-intensive decision process cannot rely on purely, sentimental choice of species depending on how much fur or how big eyes they have, because we are not really in animation production, but it's a serious business of monitoring biodiversity neutrally. It's very important that we use the technology. The twin that we're building is looking on the sampling patterns that we've been doing so far and directing future sampling effort to the areas where sampling didn't happen yet. Basically making it even and inclusive and covering, so the digital representation of DNA detected biodiversity is adequate compared to what's actually going on in nature. I think the most important end users of this use case will be stakeholders where these cryptic habitats are important. And if we take soil, that automatically brings agriculture and silviculture into the game, because healthy soil and biodiversity-rich soil, they are connected directly with the stability and complexity of the plant communities relying on them, and that affects both wild meadows and unmanaged old-growth forest, but also land used for food production and land used for silviculture for production of timber. And I think it's also important for the public-facing outputs of this twin, because in our language, terms like forest cover very different things. The pine plantation and the 600 years old forest that nobody cut, in most languages we would use the same word to name these very different communities. And if you look from the airplane, it's green enough, forest enough, because there is enough canopy cover, everybody's happy. But if you look at the complexity and the composition of species there, eDNA will be the first technology to reveal the differences and how much more rich and how much more complex and therefore stable the natural systems are. Similar and maybe even stronger patterns are discovered when you compare the arable lands with the meadows managed and unmanaged. For this digital twin, we will need to use broader and bigger masses of data, because DNA detection is done through sampling many species at a time, and sequences can be in thousands and hundreds of thousands per sample. The speed of data generation is very fast, so even if your number of sampling sites is relatively small, the data accumulation becomes very, very rapid, which puts specific challenges on the data processing. You have to handle your data so that no sequence or sample related information is lost, and then you have to put together sequence identification pipelines which should be powerful enough to catch up with your modeling needs downstream. So once again, like with all use cases in the BioDT project, we are trying to reach and push the limits of what technology allows us to do, documenting and modeling biodiversity. We only have a few use cases actually in the project, which is having very brave name, Biodiversity Digital Twin. And I'm not sure if humanity will actually ever be able to model something as complex as biodiversity. What we are trying to do is we try to put together parallel modeling processes and see if we can model very different and maybe unconnected or loosely connected processes together. It's not modeling biodiversity as such. Even modeling individual aspects of biodiversity, life in a single pond or model of blood circulation of a single organism, is already a crazy complex task. And so even like attempting modeling, not all, but at least key processes of biodiversity in a given country or a subcontinent such as Europe is only a faraway goal towards which we can work. And that's what we're doing. We're prototyping something that can help us understand and predict digitally certain processes, but not modeling biodiversity as such. EU aims to build systems that allow researchers and policymakers to make informed decisions and data-driven decisions, and to push the limits of research. So with the Twin, which predicts and directs future eDNA sampling, we can move towards a more adequate representation of Europe's biodiversity faster than without that. Choice of sampling sites for any sampling, not only eDNA sampling, can be influenced by very different factors. It can be convenience or familiarity with the sites. You may be working on the field station, it's easier for you to grab soil here and there. It can be informed by the land use or by the distribution of biotopes. You can randomize your sampling sites, and all these choices give you different picture of what's biodiversity, DNA detected or not. So to help this process, this digital twin will guide the selection process of the sampling sites based on the information we have about past samples and the past eDNA model.